Hello, everyone. Kerala hosts millions of interstate migrant workers. Their health records are fragmented. As workers move between districts, their medical history often doesn't follow them. Many speak languages that local health workers don't understand, and they fall outside what India's National Health Mission system was originally designed for. The result is missed vaccinations, diagnoses that disappear when a worker relocates, and no early warning when similar symptoms begin appearing across a labor camp. This is exactly how diseases like tuberculosis can spread unnoticed until they become much harder to contain. JeevanLink addresses this real and currently unsolved problem. A traditional form-based application isn't enough. A worker who reads Hindi may not be able to complete a Malayalam form, and busy clinics don't have time to manually compare hundreds of records looking for risk patterns. Our agent-based approach solves both challenges. Workers interact naturally in their preferred language through conversational intake, while a background agent continuously scans health records for potential disease clusters. By dividing responsibilities among specialized agents with limited tool access, the system remains scalable, secure, and suitable for deployment in real public healthcare environments. JeevanLink is built using Google's Agent Development Kit, or ADK. A root orchestrator coordinates 3 specialist agents: an intake agent, a health records agent, and a translator agent. A 4th background agent independently monitors data for emerging health risks. All 4 agents communicate with the backend through a custom MCP server exposing 5 secure tools. The platform includes role-based access control based on user role and district, field-level encryption for diagnoses, medications, and contact information, and complete audit logging for every access request. Now let's look at the demonstration. First, we retrieve a worker's health record using the command line interface with the correct role and district. The authorized health worker successfully receives the decrypted record. Next, we repeat the same request from a different district. This time, access is denied, demonstrating district-based authorization. We also inspect the audit log, where both the successful and denied access attempts are securely recorded. We then execute the risk scanning command. The background agent analyzes the available records and flags a suspected tuberculosis case using a deterministic pre-filter. Finally, we demonstrate the orchestrator by registering a new migrant worker in Hindi. The translator agent automatically converts the conversation, allowing the intake process to continue seamlessly across languages. A quick look at the MCP server shows the 5 available tools, while the encryption module demonstrates how sensitive fields are protected using Fernet encryption. JeevanLink is built with Python, Google's ADK version 2.3, and a FastMCP server for secure tool access. Sensitive information is protected using Fernet encryption, and the application is designed for containerized deployment using Docker and ADK's built-in API server, making it ready for platforms such as Cloud Run. The complete source code, setup instructions, and documentation are available on GitHub. Thank you for watching. JeevanLink delivers portable, language-agnostic health records for migrant workers, with proactive health risk detection built in.
Kerala has over 2 million migrant workers. Most of them have no health records that follow them when they move between districts. They speak Hindi, Bengali, and Odia, not Malayalam, and nobody catches it when multiple workers from the same labor camp show up with the same symptoms. JeevanLink is a multi-agent AI system that solves all 3 problems: portable records, language translation, and automated risk detection. Here I'm logging in as Anita, a health worker assigned to Ernakulam district. I'm looking up worker MWKL1001. The system decrypts his record on the fly. You can see his name, Abdul Karim, his diagnosis of mild anemia, his medications, and his vaccination history. All of this was encrypted at rest and only decrypted because Anita has the right role and the right district. Now I'm using the same account, but this time I've changed the district to Thrissur. Abdul Karim's record is in Ernakulam, so the system immediately returns access denied. This is role-based access control in action. Every access attempt is written to an append-only audit log. Here you can see two entries. The first was allowed, and the second was denied. Both include the timestamp, user ID, action, district, and result, providing accountability for every access. This is the alert agent's pre-filter running. It scans records for risk keywords like suspected TB and fever clusters. It found one record, Suresh Mahato in Thrissur district, with suspected pulmonary TB referred for a sputum test. In production, this would run automatically and alert the district health office. Finally, any health worker or even the worker themselves can look up the nearest government migrant health clinic. Here it's returning the district migrant labor cell in Thrissur with a contact number. In production, this would use a live NHM facility API. JeevanLink is built on Google's Agent Development Kit with a custom MCP server, field-level encryption, role-based access control, an audit log, a CLI skill surface, and a Docker deployment.